Chloroethane reduced in the presence of zinc and dilute HCl gives ethane by the removal of hydrogen halide. Potassium salt of carboxylic acid reacts with water, electrolysis takes place, gives alkane. Alkanes are insoluble in water but soluble in organic reagents are such as benzene, ether, etc. Hello students, I am Ramya, lecturer in chemistry from Vidhyaashram, the Temple of Excellence, Mysuru. Today we are going to discuss about introduction to hydrocarbons, classification of hydrocarbons, methods of preparation of alkanes, physical properties of alkanes, chemical properties of alkanes, conformations in alkanes, nomenclature of alkenes, methods of preparation of alkenes, physical properties of alkenes. Hydrocarbons. Hydrocarbons are the group of compounds containing carbon and hydrogen. They are classified into aliphatic, alicyclic and aromatic hydrocarbons. Classification of hydrocarbons. Hydrocarbons are classified into open chain alicyclic and closed chain alicyclic, acyclic. Such in open chain acyclic compound further classified into saturated and unsaturated compounds. In the case of saturated compounds, we have carbon-carbon only single bond, that is alkanes. In the unsaturated hydrocarbons, we have two kinds of carbon compounds, that is alkenes and alkynes. Alkenes are the compounds which is containing carbon-carbon double bond, and alkynes are the compound containing carbon-carbon triple bond. Closed chain or acyclic compound further classified into alicyclic compound, that is cycloalkanes or cycloalkenes, and aromatic compounds, that is arenes. Methods of preparation from alkyl halides. By Wood's reaction, alkyl halides reacts with metallic sodium in dry ether, gives higher alkanes by the removal of sodium halide. For example, bromomethane reacts with sodium in the presence of dry ether, gives ethane, and bromoethane reacts with dry ether, gives N-butane. N means normal chain or else straight chain. By the reduction of alkyl halides, alkyl halide are reduced with zinc and dilute HCl to give alkane. Reduction can be done by two methods. One is by passing hydrogen gas in the presence of zinc and dilute HCl, and another one is by using strong reducing agent like lithium aluminum hydride. For example, chloroethane reduced in the presence of zinc and dilute HCl gives ethane by the removal of hydrogen halide. From unsaturated hydrocarbons. As you know that unsaturated hydrocarbon means the compound having carbon-carbon double bond or the carbon-carbon triple bond, or else alkenes or alkynes. Hydrogen gas adds to alkenes and alkynes in the presence of finely divided catalyst like platinum, palladium or nickel to give alkanes. This process is called hydrogenation. Platinum, palladium catalyst at room temperature, while nickel requires higher temperature and pressure. Here propene reduced in the presence of nickel at 250 degrees Celsius gives propane. Propine reduced in the presence of nickel at 250 degrees Celsius gives propane. From monocarboxylic acid, by decarboxylation of fatty acids, sodium salt of aliphatic monocyclic acid on heating with soda lime. Soda lime is a mixture of sodium hydroxide and calcium oxide gives alkane. This is sodium salt of carboxylic acid reacts with strong alkali like sodium hydroxide and calcium oxide, that is the soda lime, gives alkane. For example, sodium salt of acetic acid reacts with soda lime, gives methane. This reaction also called as decarboxylation reaction because here removal of carbon takes place. By coal-based electrolytic method, when aqueous solution of sodium potassium salt of aliphatic monocarboxylic acid is electrolyzed, alkane is formed at the anode. Potassium salt of carboxylic acid gives acetate ion and potassium ion at the anode. This reaction takes place. Here the acetate ion gives acetate free radical and methane free radical. The 2-methyl free radical gives ethane. At the cathode, water hydrolyzed gives hydrogen free radical. 2 hydrogen free radical gives hydrogen gas. In general, electrolytic decarboxylation can be represented as potassium salt of carboxylic acid reacts with water, electrolysis takes place, gives alkane by the removal of carbon dioxide, hydrogen and potassium hydroxide. Physical properties of alkanes. Alkanes up to 4 carbon are gases, that means C1 to C4 compounds are gases. Alkanes up to C17 are liquid. The higher member alkanes are solids. Alkanes are insoluble in water but soluble in organic reagents are such as benzene, ether, etc. The boiling point of N-alkane increases with increase in the number of carbons or a number of molecular mass. As the branching increases, boiling point decreases. Chemical properties of alkanes. Halogenation. Halogenation takes place either higher temperature at 573 Kelvin to 773 Kelvin in the presence of diffuse sunlight or UV light, that is ultraviolet light. Methane undergo halogenation in the presence of diffuse sunlight gives chloromethane. Methyl chloride undergo halogenation gives dichloromethane. Dichloromethane undergo halogenation gives trichloromethane, that is chloroform. Trichloromethane undergo halogenation or chlorination gives tetrachloromethane or carbon tetrachloride. Mechanism of chlorination of methane. Step 1. Chain initiation. Chlorine molecule absorbs energy from sunlight to give chlorine free radical. This is chlorine free radical. Homolytic cleavage takes place. Step 2. Chain propagation. Chlorine free radical reacts with methane to give methyl free radical and HCl. Methyl free radical attacks chlorine to form methyl chloride and chlorine free radical. Step 3. Termination. The free radical combine to form the product. Here chlorine free radical gives chlorine gas. Methyl free radical combines to form ethane. Methyl chloride free radical forms methyl chloride. Combustion. Alkanes on heating with air or oxygen get oxidized to carbon dioxide and water with the evolution of large amount of heat. Methane on combustion in the presence of oxygen gives carbon dioxide and water. This is exothermic reaction. A large amount of heat liberated so that delta H is negative. Due to the evolution of large amount of heat during the combustion, alkanes are used as fuels. Incomplete combustion. Incomplete combustion carried out at limited supply of oxygen or air result in the formation of unburned carbon particles, that is carbon black, which is used in the preparation of ink, printer ink, etc. Methane by the limited supply of oxygen gives carbon and water. Controlled oxidation. Alkanes on heating with regulated supply of oxygen at high pressure and in the presence of catalyst give different products. Methane reacts with oxygen in the presence of copper at 523 Kelvin and 100 atmospheric pressure gives methanol. Methane on oxidized with molybdenum oxide gives methanoldehyde. Ethane on oxidation in the presence of manganese diether gives ethanoic acid by the release of water. Ordinary alkane resist oxidation, but alkanes having tertiary H atom, that means hydrogen atom, be oxidized to the respective alcohol by the potassium permanganate. Here potassium permanganate acts as strong oxidizing agent. Oxidation can be done by two methods. One is by passing oxygen in the presence of catalyst. Another one oxidation method is by using strong oxidizing agent like potassium permanganate or potassium dichromate or chromic acid. Isomerization. N-alkanes on heating in the presence of anhydrous aluminum chloride or hydrogen gas, they get isomerized as branched chain of alkanes. N-hexane gives 2-methyl pentane and 3-methyl pentane. Aromatization. N-alkanes more than 6 carbon atoms when heated with 600 degrees Celsius at 10 to 20 atmospheric pressure in the presence of oxides of vanadium and chromium or molybdenum supported over alumina give aromatic hydrocarbons. It is also called reforming. So this is N-hexane in the presence of these catalysts, that is chromic acid, molybdenum acid, vanadium pentoxide at 773 Kelvin to 10 to 20 atmospheric pressure gives an aromatic ring like benzene. Reaction with steam. Methane reacts with steam at 1000 degrees Celsius in the presence of nickel catalyst to give carbon monoxide and hydrogen. It is used in the production of hydrogen gas. Pyrolysis. The process of decomposition of organic compounds on heating at a temperature of 500 to 800 Kelvin is called pyrolysis. The process of thermal decomposition of alkane into smaller molecule is called cracking. This compound can cuts into a smaller compound. This process, what we call it as cracking of hydrocarbon. Conformation in alkenes. Different spatial arrangement of atom in a molecule which can be converted into another rotation at the carbon atom. Single bond are called conformation or conformers or rotamers. Conformation of ethene. In ethane, the tetrahedral methyl group can rotate around the carbon-carbon bond to yield several arrangement. Out of this, two extreme arrangement are eclipsed form and straggled form. Methods of preparation of alkenes. From alkynes on partial reduction with hydrogen in the presence of Linder catalyst, which is derived with quinoline or sulfur, gives cis alkene. Cis means both the hydrogen or both the group of atoms are in the different carbon are laid with the same plane. Example, ethane reacts with hydrogen or reduced with hydrogen in the presence of palladium catalyst gives ethene. Propane on reduction gives propene. Alkynes when reduced with sodium in liquid ammonia gives transalkanes. In transalkanes, two similar group are at the opposite side. from alkyl halide. When alkyl halide heated with alcoholic potash, dehydrohalogenation takes place, giving alkenes. In this reaction, halogen is removed from beta carbon. Hence, this reaction is called as beta elimination reaction. So, this reaction is called as beta elimination reaction. This hydrogen is removed when reacts with alcoholic potassium hydroxide. Halogenation follows the order tertiary alkyl halide is greater than secondary alkyl halides is greater than primary alkyl halide. The rate of reaction varies with the different halogen, such as iodine reacts with easily than bromine than chlorine. From vinyl dihalides reacts with zinc to form alkene. This reaction is called as dehalogenation reaction. Vinyl dihalide means halogen attached to the different carbon. From alcohols, when alcohols are heated in the presence of concentrated sulfuric acid, they undergo dehydrogenation, give alkenes, that is beta elimination reaction. Physical properties of alkenes. The first 3 members are gases, next 14 members are liquid, and the higher members are solid in nature. Ethene is a colorless liquid used in a paints, sweet smell, and all other alkenes are colorless and odorless, insoluble in water and fairly soluble in organic solvents, that is non-polar solvents like benzene and petroleum ether. The boiling point of alkene increases with increase in the molecular mass. N-alkanes have higher boiling point than branched alkanes. In the next session, we are going to discuss about chemical properties of alkenes. Thank you.